Hello together. Today we are presenting you the topic BCM-B and BCM-F. But what exactly is it? Mirko Metzner will explain it to us because he's the expert for the digital service.
Yeah, hello together. Yeah, I think it's a really good and interesting question. I've brought something with me to show it to you. So finally we have some hardware elements here, but at first I think we should ask not about what is it exactly, so we should better ask about the reason why we will have it in the future.
Okay.
So if you take a look on this, we can take our picture that we had in our last video that we have done. So finally here we have our PLC control on one side, our gripper on the other side. Communications between is here listed as a black box. In this black box we have put in some things in the last video, but now we have to think about the connections between. So not the tools, so just the connection. And what could it be? For the moment it's the cable. So you have a cable that connects everything together. But what would be a possibility for the future? Do we need a cable in the future? I think it's a good question. It's a question you can also ask you about of your own life. Do you need a cable for everything in your life today? So a telephone has no cable. You have your cell phone, you have your laptop. Anything is together with Wi-Fi, with Bluetooth. So finally wireless. Your headphones, for example. So for us in the normal world, in the modern world, it's not a big thing to take it wireless because it has big benefits. You don't have a cable that has a small range of freedom for you. You don't have a problem that the cable gets broken or gets unconnected. Finally, big benefits that you can use for your daily life. But it's not a good thing for the daily life. It's also a good thing for the industrial sector because the things you have there are the same limitations that you would have if you use a cable in your normal life. Yeah? For us, it's also interesting. What can we do when we don't want to use a cable? How should it look like? How could it work technically? And this is a really good question, a big question, and I think a big question for today. And maybe in the future it's not a big thing because it's a normal way to do something. Yeah?
Of course.
For today, we have this wireless technology behind it. So if you don't have a cable, we need something else. Yeah, it could be an optical thing, but the normal wireless thing, I think here is the best because it's most reliable and it's also the most safe way to do this job. So what we have today are two products. I can show it to you on the table. So finally here we have the rich communication module that is worked out as a box. Yes, like you see here on the table. Yes, so you can use it everywhere, not just on a robot. So on any kind of industrial machine, you can use this module to connect an IO-Link device with finally with the network or with the control unit that is inside of this machine. So with this box, you don't need a cable to send some signals or some informations. So it's a big benefit that you can use everywhere. And finally, the other thing here is the module for the flange. So it's a combination in this case, a combination of a match system. So you have your fixed part and your loosened part for match. But here you have an addition on the bottom. In this addition, there's the electronics and everything that you need to make it wireless. So here you just need a cable to put in the energy, and the information is sent completely wireless in the system. If you now take a deeper look on our different modules, we have the box version here on this side. So here you can connect your IO-Link device, and on the other side you can connect your power, and anything is done. So you have the possibility to send your IO-Link signal in this box, and from this box it goes wireless to your control unit. If we see the other option, the flange version, there we have a possibility to use this included part. It includes the wireless element and it includes also the match component. And this match fixed part is usable with any loosened part that we have on the match system that speaks IO-Link. So you just can connect your gripper that is also adapted with the match system and put it together to one complete unit. So finally here is the flange of the robot. Here you have your connector for the energy that goes into the system. You have your gripper in the end, and the information is sent wireless to your control.
Oh, okay. So, and over there is a robot. Could you
Yes,
show me
we brought something more with us. So we have also our exhibit module, and we can go over there to take a look on a system that is assembled to a robot into a real application. Yeah. So here we are. So we have something installed here that shows us both versions of the BCM module. So finally here we have the box module in the bottom of the unit. In this module we put on power with an accumulator, and the connections that goes out is IO-Link that goes into the match fixed part. So finally, if we connect here a gripper on this, we have just a little circle that runs without of some cables that comes from the outside. So information is brought wireless into the BCM, and the connections for the power is done here by an accumulator. So this is really interesting if you want to have mobile applications in your industrial sector. You have all benefits here on your side. So you don't have to think about how to get the informations from one point to the other point.
Very flexible.
Yes, really flexible, yeah. Another option is the flange version that you see here. So this is the connection here with the gripper, with the match loosen part, the match fixed part, and here on top the wireless IO-Link unit. This unit here has a cable that goes into the robot, and this cable is just there for sending the 24-volt power from the robot into our module. So here with these versions, it's not necessary to put some information wiring inside of the robot or external on the robot. You not just need the power that is available on top of the end-of-arm tool connector.
Thank you, Mirko, for this example. Now I have some questions to you.
Okay.
How secure is this radio transmission?
Yeah, it's a good question. If you talk about wireless technology, yes, there's not a direct connection like on a cable. So it's a question, I think that has everyone. Will it work? What happens there? So finally, it's a protocol that is more than 6 times more reliable than a Wi-Fi protocol or Zigbee protocol, for example. And it's a deterministic protocol. So it's wireless IO-Link. And this wireless IO-Link uses a deterministic behind that makes it really safe, because the data that is sent is asked and processed directly when it has sent it. So if something has sent it that was not complete, so if something had get lost, the system will send it again, and the system will take care that everything comes complete as needed from one point to the other point.
And do I always need a separate master for the module?
Finally, one master can use up to 40 units on it.
Oh, okay.
So it's a really easy thing to grow up the system. If you start with just one gripper, and if you need another one, you can just pair them to your master and then use this number of grippers that you need. With these 40 devices, you can use on one master. You can also add a line of up to 2 more masters, so about 120 devices in one line. So I think it's also usable for really a big machine.
Yes, of course.
Yeah.
And will there be more products in the future?
Yes, for sure. For us, the wireless technology is an interesting field, and we see this wireless technology as a new standard in the future, and also we will grow up our products in this direction. Yeah.
Okay, perfect.
You're welcome.
Thank you, Mirko, for your answers and your examples about the topic wireless IO-Link. And if you want to get more information, please check our landing page for the digital exhibition. Follow us on LinkedIn and YouTube to be updated.